Hi everyone, we are back again with yet another interesting problem named birthday chocolate. This problem is from Hakerrank and here is the link of this problem. So before we start solving this problem, let's start taking a look what the problem is all about. So this problem is really about a chocolate, interesting way of distributing a chocolate where we have to distribute a chocolate to somebody according to the person's birth month and birthday. For example, here in this case you see there's a chocolate which is having different squares. So each square is having an integer written on it, and the person having the birthday is having on second month and third day, which means 3rd of February in this case. So the idea is to give this person two consecutive squares from this chocolate bar where the sum of these integers turns out to be equal to the number of days. So in this case the sum needs to be 3. So 1 plus 2 is equal to 3, and because we have to give two blocks. Had it been maybe April, so we had to use 4 blocks, 1 2 3 4, any 4 consecutive blocks, which can be these 4 and which can be these 4. Okay, there are some constraints. We'll talk about them constraints again, but first of all let's try to understand the problem a little more. So to understand the problem, let's use the advice from Albert Einstein, where he says that if I got an hour to solve a problem, I'll spend 55 minutes thinking about the problem. So let's go back to the problem, and so in this example we are having a chocolate bar having 10 different squares numbered 0 to 9, and each square is having a number written on it ranging from 1 to 5. There are some random numbers, and the person to whom this chocolate should be distributed, or a segment of chocolate should be distributed, is having the birthday on 11th of April, right? Which means the person needs to given 4 squares from the chocolate, 4 consecutive squares from the chocolate where the sum of these integers turns out to be 11. Okay, so initially we have this count set to 0, and we have the number of squares in the chocolate bar as 10. So as we move along, we'll do, first of all, because we have 4, the month is 4, we have to sum up the 4 consecutive segments. So it's like if you start with any I, then with I plus 0, I plus 1, 2 and 3. Okay, so let's take a look at the first one. So first one is having between 0 to 3, sum turns out to be 10, and because the sum is 10 and which is not equal to the day, the count remains 0. The moment we move next between 1 to 4, the sum turns out to be 11, which equals the birthday, which is 11, so the count increases. Same way we keep moving. Once again we hit a segment where the count becomes 11, which equals to birthday, and the count increases to 2, and we keep on moving. We keep on moving till we hit the last point. So where, if moving ahead, then I, which is the value, which is the segment number, which becomes, or the square number becomes higher than n minus m. So for example, here 7 is greater than n minus m, which is 10 minus 4, 6. Okay, so that's why we are stopping here. So this actually takes us to an algorithm, and we start implementing algorithm in the first space, where we first of all have a segment of algorithm which simply calculates a sum from a starting position. Okay, so we have this first function which has as an input the squares, the array of squares. We have the starting position and the number of squares. Okay, so which actually in our example becomes m. Okay, this was an I. So we have start this sum of 0. We move from 0 to number of squares position, right? I is less than num squares, and each time we get the value from the starting position plus I, as we have starting position plus I. So I plus 0, which is like starting position, plus 0 plus 1 plus 2 plus 3. So that's where we reach, and once we have the sum, we simply return the sum. So this becomes a very simple part where we calculate this sum. This function calculates the sum as indicated here. Next part is integrating it into our algorithm, where we compare whether the sum equals to our day. So once again we have this another function created, get possible combinations, which is actually giving us the right result that we want. We pass it the squares, the number n, which is the total, how many squares do we have, the date and the month. Once again we are starting from starting position 0 to moving to n minus m as we had in the algorithm, as you can see here. So I has to be n minus greater than n minus m, so here we have to run till I remains less than or equal to n minus m, and then we keep on moving the starting position. Each time we get the sum of squares, we need to compare it against the d. If it matches, then we simply increase the count and return the count, which is like we have a variable named sum here. We could have it any name, so we're just using sum here. So before we move ahead, we need to really test it. So I'll show you this test. So this is the same example we had of the 10 squares that we have in the presentation. So we had these inputs, 4th of April, which is month is 4th and date is 11th. The expected combinations is 2. So we're simply saying execute test, where you have test name, the squares, n, d, m, and what do you expect. So let me just show you what the execute test runs. So it has a test name, it takes the square and rest of the variables. All that we are doing is simply, because we already had this function implemented, we pass these parameters of the function, got the actual. If the expected meets the actual, we call the test case success, and that's where the test name makes a significance, just to distinguish different test cases. And if it fails, we report with what is actual and what is expected. This helps us improve our logic and do a fast implementation. On similar lines, we have other tests where we are having different inputs. So this one matches, where this one doesn't match any, so this is 0. And there you have the 5th month, so we have to sum 5. We have to make the sum of 5 squares. And as we run, we combine this into test suite, and we run the test suite. All these test cases pass. Had any of them failed, we would have seen a problem here, and we could have just gone and fixed the logic. Now this Hakerrank was expecting us to have this function which reads from the standard input, so we have to integrate standard input, and we'll do it in an interesting fashion. So once again, take a look. So this is the kind of input format. So first of all, you have the number of squares, the integers written on the squares, the day and the month. This is what the input is, and this is what we'll make our application or the program capable of. So we'll write another function which simply says squares is 100 squares we'll take. Why? Because the limit here is 100. We just want to be sure that we are always having the same number of squares, right? And initialize this n, d, m, and possible combinations 0. Read the number of squares, populate the value of the square from the command line, as in the condition it says the value should be between 1 and 5. If it is not, then we're returning -1, because this is the constraint here. And we are then scanning the day and the month. We have to follow the same format or the same structure that is in the input. So we have to first read the n, that's what we are doing, first reading the n. Then you have to first read the array values. This is what we are doing here, we're reading the array values in this loop. Then you have to read d, which we are reading d here, and then the final one is n. So we have to ensure that we match the exact expectations of the input. So once we have got the input, we once again call the same function as we had in our hard-coded test. Pass this to this function and get the possible combination. This is what we result. As we call this function from the main, we read the input and we print the output. So this is the output. So this is the input that we had. So once again the same sample, which is 10, and rest of the integers in the squares, and the day and the month, and the expectation was 2 was executed. We are getting this 2. Okay, that's really it. And we need to, I mean, in terms of the program we are done, but we can extend it a little bit further, where we can actually uh, place this entire input in a text file like this. So we have this n, the segment values, the month, day and the month, and you can actually pass it like this. So there you have to do not have to supply the input from manually from command line. So this will automatically get it, and as expected it is giving the right result. And this can be further extended, because this becomes a very interesting piece which can allow us to script it further and run multiple test cases. And we can use shell scripts to run multiple test cases. This is a very simple test script we have written. They have, for each test case we have different test case files, and we have a test case name, we have an expected value, then we simply say test result. Once again the same commands as we had on the command line. We compare the expected and actuals. If it matches, then we say okay, otherwise it fail, and we report expected and actual, and we can run any number of test cases. This allows us to do multiple tests. Okay. So we have run our test cases, and this is there. We are having the results here. If you want to take a look at the code, final code is available at this site, along with the test cases and test files and the shell script. This is really it. And if you want to know more about us, want to work with us, this is our website. This is for it. This is for now. Thank you. Bye bye.